Hello YouTube, I am Arend Peter and today we are making another tutorial. In today's tutorial we're going to be talking about how to generate Terraria style terrain in a game engine called Unity. I don't think it should be terribly complicated. There'll be some math and have some loops and that sort of thing. But the new thing we're going to be using in the fundamental part is the Perlin Noise algorithm. So if you come in ready to learn something new, then we should have a lot of fun. So let's go ahead and jump into it and see what the final result will look like. And here it is. This is what our final product will generate, and it's just random terrain, and I can unload it and reload it, and you see every time I play it will come out with random terrain. Right now it's randomly selecting a seed, but if you wanted to, you could in theory plug in the seed you want and it will regenerate the exact same terrain as we have here, or the exact same terrain over and over again, basically, if you have the same seed. So yeah, that's what we're going to be doing today. So to get started, we're going to make a new project. So I'm going to go to File, New Project, and I'm going to call it Terraria. And doesn't matter too much, but we're going to make a 2D project just to make some of the initial settings a little easier for us. And you see my lovely background. Well, it's generating Unity. It's a default Windows background. And now we are here. Cool. So real quick, I'm going to change the camera background because I think that blue is kind of ugly. So I'm going to go to yellowy and a lightish, whitish yellow. There we go. So I did that by just clicking on main camera and then going under the background settings of the camera and changing that there. Alright, now that we have that, we can go ahead and add in our textures, our sprites. So I went ahead and generated two gradients in Paint.net ahead of time. I'm just dragging them in from my desktop over to this assets region, and there we go. When I drag them, they came in as sprites, so you see them right there. So yeah. And I can drag them in here, drag them in. Oh no, I drag them into the hierarchy over here, and you can see I can add it over here. And I'm gonna actually rename this to dirt with a capital D because that's nicer. And I rename things by pressing F2 or by renaming them here or by hitting right click rename. All right. So now that we have the dirt up here, it actually did some stuff behind the scenes to make it Unity compatible rather than just an image. So if I drag it back here, you see it's now a prefab, a Unity object. And that's what we want. That's just our dirt image. And I can do the same thing over here. So transfer and call it grass. And I can drag it back here. And we have our grass prefab. Cool. All right. So we have all that. That's all we need. Now, oh, and by the way, I just threw these together real quick. You could probably, I'm sure you could easily throw something better together. But if you wanted to have these, you could download the source code and go and pick those out from over there. So that's a link in the description for that. And for my testing, I found this 100 by 100 size worked well for what we're doing today. So that's my input there. Okay, now we can start writing a script to generate all of our objects, which we wanted. To start off with, we're going to do a simple grid. Let's see. So we're going to make a script do that. Okay. So I'm going to rename this game object to generator, and I made this guy by right-clicking here and hitting create empty. By the way, so right-click create empty, and we're going to name it generator. Its only purpose is to hold the script. So then we're going to create a new script. So I'm going to add component, new script, and we're going to call this generator. And then it pops up down here in my assets. I double click that and it'll open up in the code editor that I have selected. So right now I'm using Visual Studio Code. The default code editor is MonoDevelop, which people have mixed opinions about, but you can decide if you like it or not. And yeah, so you can figure that out yourself. This just happens to be mine. Alright, so what I just did is I just removed some of the clutter that we're not going to be using, just some of the comments and the update method. So up here I'm going to create a variable. I'm going to call it public game object dirt prefab. And that's going to be our dirt. And notice I made it public, which is kind of a big deal because that means that it can be changed from the editor. So if I save this code, bump back to the editor, click on my generator, you can see this now has a dirt prefab field, and it even parsed through my camel case of the variable and made it legible. So we're gonna go ahead and drag in the dirt prefab we made earlier up in there, so that way when I tell it to make dirt blocks, it knows what I'm talking about. And another minor thing that in the scene editor, I can't see this empty object, so I click up here and make it one of these icons, so now I can see it. So there it is. Minor things. Alright, now I can go to the code, and I'm going to make a separate method just to make it clean as possible for generating the grid, so I can call it regenerate. And then we're going to make it down here. Make it private because it's only used in here, not used elsewhere. Void is not giving anything back, and regenerate is the name. Takes no parameters. Okay, so we're going to need a nested loop to go over the whole grid. So we're going to type that out real quick. I hate that autocomplete. So annoying. Int I equals 0, I less than. Let's see. Oh, let's not start out 0. So let's see. For now, let's go from -16 to 16. So there we go. And I++. Get rid of view. Not that way. Okay. Cool. Now I can do the same thing again. Please don't do it. Yes. Okay. Equals -16. J less than 16. J++. Awesome. So now in here, let me think. So this is going to iterate over our rows. No, this will iterate over our columns, I guess. Columns. And this is going to iterate over our rows. Y values. Okay. And now that we have an X and a Y, or an index for an X and an index for a Y, we can make the object for this particular spot in the grid. So I'm going to use instantiate to create a new instance of our game object. So instantiate. Okay. And this takes 3 parameters. Number 1 being what we're making, which can be dirt prefab. We're going to make just all dirt for now. Number 2 is where do you want to make this thing? So we're going to make a new vector 2, which will represent where it's going to be. Vector 2 takes in 2 parameters, an X and a Y. So we're going to give it our I and our J. There's more to it than that because I is just from -16 to 16, but I'm going up by 1 each time. So this really only works if they're 1 wide and 1 tall. So since that's probably not the case, we're going to go ahead and figure out how wide and how high they are, and we're going to take that into account down here. So I'm going to say float width equals dirt prefab, our prefab that we want to know the width of. We're looking at transform. Transform has all the information regarding to the geometry and the scaling and the location of the thing. We're specifically interested in the sizing, so we're going to talk about lossy scale. There's local scale and lossy scale. Local scale is relative to its parent. Lossy scale is relative to the world. In this case, you could use local scale. Doesn't matter, but I'm going to use lossy scale. And we're saying x, which is the width component of the scaling. All right, we follow all that. We're going to go through it again. We're going to talk about the y for the height, and then we're going to call this height. Cool. We have width and height. Now we can simply multiply our I by the width, and I can multiply our J by the height. And that's all for the position. Now the last part is rotation. And for rotation, we don't really want to rotate at all, so I'm going to pass in quaternion.identity. And there we go. There we go. This should generate a grid of things. Hopefully. So I saved it. I'm going to jump over to Unity, and hopefully it's not giving me any errors. Fingers crossed. Task Manager says it's doing fine, but not letting me go to console. Let's resize. I can save it. I'll save it real quick. Because I haven't done this yet, I'm just going to go ahead and save this scene. So it'll be Terraria assets, and we're going to call this terrain.unity. There you go. You can see that the scene is now there. But, okay, there, let me go to the console. If there were errors in my code, there would have been an error here. So there's no errors in the code, so we should be able to hit play, and it should work. There we go. We generated a grid of things. If I go to my scene, I want to make it roughly fill the region of the camera. So if I hit main camera, that's our camera region. But we're making bunches more blocks than that. So I'm going to need to size up the camera. Let's see. So if I click on my camera, it now has a size of 5. If I make it size of 10, yeah, that works. It's still too big. I'm going to need to size the Y's down, I guess. I guess the Y is more so from 1, 2, 3, 4, 5, 6, 7, 8, 9. That 9, 10? So if I change my code to say Y's go from -10 to 10, how would that look? Oh, errors. Okay. Unity doesn't like it when I change code while it's running, so it often gives me this error, which just means that I need to restart it. Nothing changed. This is saved. I did change the bounds for J, but it's still a square when I run it. Should be the scene. Oh, right. So I changed the size of the camera. I changed it to 10, but that didn't do anything because I changed it while the game was running. And any changes you make while the game running will reset by the time you undo the play. Okay, so I forgot about that. I'm going to open up Notepad, and I'm going to record some stuff. So when it's playing, I want the size to be 10, right? 10. And additionally, oops, why are you square? Oh, because I sized it down probably. And additionally, I want it to be like, camera. I want to move it around, so click up here, and roughly I want it to be like that. And that's about where I want it. Something like that. Okay, so that gives me, for my position, it's -0.37. Y is -0.5. I'm reading off here, and a Z is -10. All right. So now, if I unplay it, that all went away, but I can just put the information here: -0.37 and -0.5, and that works. All right. Cool. Now when I play it, it should work fairly nicely. Awesome. Very awesome. Alright. So now we've got a grid that fits in here nicely. Just as a quick kind of bookkeeping or housekeeping, whatever, I'm gonna, rather than have these just be hard-coded, these values hard-coded into the loop, I'm gonna make variables for them just so it's more clear what we're doing. So our minimum x is -16. Our maximum x is equal to 16. Our minimum y is equal to -10, and our max y is equal to 10. Bam. And then we can go ahead and change them in here as well. Min x, min x to max x, max y, and min y. Bam. So the key to this Perlin noise, or the key to generating the terrain, is for any particular x value, any particular column, we want to find a random value for the height of the column. Now just pure randomness wouldn't work because it'll be up and down and all jittery and stuff. So that's where the Perlin noise algorithm comes in. So to hopefully give you some insight into how Perlin noise works, I'm gonna go online and look up a tutorial. So I'm gonna look up Perlin noise, and we can click the second link. This is freespace.virgin.net, Hugo, Elias, Models, and Perlin HTM. This is a pretty good article that I've read through, and I found it very helpful for explaining these concepts. So here's the basic idea. We have this grid right here. This is what pure noise would look like. So for every column, we just select a random point. So that's noise. So this particular graph is created with a distance of 1 between each sample point, I guess. So if you're filling in the area in between, it would look something like this. So in this case, they use some sort of sine curve to fill in the area in between. They interpolated between them. So then that's one of the keys, where you generate a bunch of random points and you fill space in between them in this manner. So then they establish some technical jargon that they use, which amplitude indicates how large the random values can be, and frequency indicates how often you sample. So this one has 14 samples. If you had 28 samples, it would look a lot more jittery. Okay? Cool. Alright, so then we look at this. Now this is the key thing. We're varying amplitude and frequency as we go. So over here, we have a high amplitude. You can see the values vary greatly. It can be really high or lower. But on the right side, we have a very low amplitude, so you can see there's barely a difference between their lowest and highest. So just go up and down very slightly. Okay, that's the first variable, and the second variable is frequency. So this one, yeah, the values vary a lot, but you see they haven't chosen a lot of random values. You can see, let's see this one here, one here, one here, one here, one here, and they're just interpolating between those values. They're filling in the space between them using this whatever technique they're doing. So you can see this isn't changing very much because they don't have a lot of random samples. Whereas the next one, you can see they have more random samples. It's changing more. It's changing more often, but the amount it changes by is less because the amplitude is lower. So you follow this pattern. You keep halving the amplitude and you keep doubling the frequency, and you end up with something like this, which changes a lot, but it doesn't change by very much. Got it? And then you add them together, and you get this type of noise. So this is essentially what we want to do with our terrain. And it's cool because if you compare this to the original graph, it has that same general shape. You can see there's big patterns happening. But at the same time, if you look more closely, there's a lot of little stuff happening, which makes it seem more natural and less generated, I suppose. So that's what we're doing. I hope that makes sense. And then this is one-dimensional Perlin noise because it's only depending on x value, and then the rest of the article talks about how it can be generalized to higher dimensions and specifics of the algorithm, different interpolation types, whatnot. But that's the basis of it. Okay, hopefully that helped. Okay, so we're going to create a new class called Perlin Noise, and I'm going to call it noise. And yeah, so we need to make that class so we can use it in here. So if I hit Control N, maybe that'll make a new thing for me. Yes, it does, but I don't like the way I did that. Okay, I'm gonna go back into Unity real quick. Oh, it doesn't like something. Yeah, it doesn't recognize Perlin noise, but that's gonna change in a second. So I'm gonna create a new script, and my asset's gonna go to create a new C# script. I've been using C# this whole time. Unity can operate in JavaScript or C#, and I prefer C# because it's, I guess, a more rigorous language. Alright, so we're going to type in Perlin Noise. That's the name of our class. And then I'm going to jump in here, yada yada yada, open up code. Okay, there's our Perlin Noise. And I'm going to do a little trick that I like about Visual Studio Code is I can open up a folder. I can go into the place where I have everything stored, which is in Terraria. So I can just select my assets folder, and then over here I can see everything in this assets folder. So there's generator.cs that I've been working with, and now there's Perlin Noise that we've been working with. Okay. So generator is very involved with Unity. I use Unity functions here. Perlin Noise is going to be just a standard C# class. It doesn't rely on Unity at all. So I'm going to take away this mono behavior because that'll actually screw things up. Alright. So this is going to be, so then I take away these guys as well because they're also based in Unity, and it's just a straight class. We're going to go straight object-oriented programming on this. So I'm going to create a variable called longSeed, and then I'm going to create a constructor for this guy, public Perlin Noise, and as a parameter I'm just going to pass in the seed, and then in here we're going to set our seed according to the parameter. A very basic constructor you'd make object-oriented programming. So yeah, when we make it, we pass in the seed, and that's what it uses. Alright, so now there's going to be a function here that we're going to be calling over and over again called get noise. So let's see, that's gonna be a public as well because it can be accessed by other people. It's gonna return a integer, and it's gonna be get noise. And what we want to know for this noise, what we need, the information that we need is, tell me what x you want the noise for. What x do you want to generate this noise? And also, what's the range? So I'm giving you an int back. Do you want it between 1 and 100, between 1 and 10, between 1 and 1,000? That's what this range is to specify. Okay, so now the next thing, I'm creating for variables. I'm going to call it make int chunk size. Just make it equal to 16 for now. So this chunk size indicates, if we go back to the website, this chunk size indicates distance between the individual samples. So for this first graph, the chunk size is 1 because there's 1 between each sample, and in these ones it's a lot more. And as you go in finer frequencies, it's less. So we're going to start the chunk size at 16. So since our x ranges from -16 to 16, there should be all of 3 sample points, because there's 1 at -16, 1 at 0, and 1 at 32. All the points that are divisible by 32. Alright. So let's say, just for our example, let's say that x is, I don't know, 8. Or we'll go with 6, something like x is 6. So there's 2 samples that x falls in between. We want to know what those are. So we're going to find the one to the left first. So chunk index will be the one to the left. And we can find that using the handy dandy equation, x divided by 16. What will this be, folks? Well, let's see, x is 6. 6 divided by 16 is, oh boy, that's 3/8, so that'd be 0.375. But since these are both integer types, int x and chunk size, it will floor it down to 0. So this will give us 0, which makes sense because 0 is the next closest. Cool. So now we know which chunk index we're at. We want to figure out how far past that index we are. So, like I said, let's see, we're 0.375 past it. Let's see, maybe 22 would be a better example. Okay. So 22 divided by 16 is 1.375, which floors down to 1. So chunk index is 1. And now we want to figure out how far we are into it. So we're going to call it our progress. How far past that are we? So I want this to be between 0 and 1. 0 is we're right on top of this chunk index. And 1 is we're as far away as we could be before passing another chunk index. So we're really close to the next one, but we haven't quite passed it yet. All right. And the way we're going to calculate this is we're going to do x% chunk size. And then we're going to divide it by chunk size. And I made this a float. I made this int. Should be a float. My bad. And let's see. This is an int. This is an int. So we need to convert one of them to a float, so we can do that by just adding a cast. Or you know what? I'm going to multiply this by 1f. There. That's now we have an integer divided by a float, so it's going to give us a float over here. Cool. This percent sign. Some of you might not remember it. It's the remainder or modulus operator, and if we do, this gives us the quotient. So 22 divided by 16 is 1, meaning that 6 fits into 1. Sorry, 16 fits into x once, and then this x% chunk size gives us what's left after the division. So this will be 6 in this case because there's 6 left over after dividing by 16. I have a video about modular arithmetic, and I can put a link in the description if you are interested. Now that we know between which 2 chunks we are, between which 2 samples we are, we need to figure out random values for those things. Because remember, the values, if I go back to the website, the values at these sample points are purely random. So we just need to come up with a random value for that. So float the left random value. I'll just spell it out. Left random equals random. Ooh, no. Random. And we want to pass in our x and our range. And same over here. right random. And actually, I got this wrong. We don't want to pass in the x in the range. We want to pass in the chunk index. So chunk index. So the index for that particular sample point, and this one would be the one to the right of it. So it'll be chunk index plus 1. Okay, cool. So this function is something we're going to need to write ourselves. It's a little bit of a special random function. I want it to give me, if I give it the same chunk index and the same range, I want it to always give me the same value back. So it's not truly random, I guess. I can predict what's going to come out based off of these values, but it's vital for us to be able to recreate the same thing over and over again. Okay. So I'm going to go and make that function up here. I'm going to make it private, and it's going to return an int, and it's going to call it random, and it's going to take in an x and a range, just like our noise. Cool. All right, and I did some funky math in here to try and get this to work. I'll just write it out and explain afterwards. Alright, now I typed that, now I can explain it. Alright, so essentially the point of this section is to make a really big number. And this percent range will give us, the percent does the remainder right after we divide something, and the range is how much we, the range of values we can accept. So if you think about it, if we divide something by range, if we do a remainder on the range, the remainder we get back cannot be greater than the range, right? So think about that for a second, it'll make sense, because if the value after we find, if the remainder is bigger than range, then the range could have been divided into it again, so that doesn't make sense. So yeah, that involves some intuition on the percent. It doesn't necessarily need to be, you don't necessarily need to know that. So that's why the percent's important. Another reason why the percent's important is because, let's say range is 100. By doing this percent, that will essentially give us the last 2 digits. So if we get some really big number out of that, out of this, then the percent 100 will give us a 34. So you might say, this doesn't seem too random. The bigger the x value, the bigger this value would be. And you'd be correct. As we add more x's, the bigger this value is going to be. But these smaller digits essentially follow a random pattern. Like it's easier to predict these larger ones than it is to predict these smaller ones, because they're much more what's it called, susceptible to the various changes, and these are much easier to change. So these smaller digits essentially become random. So we're doing this percent range to basically grab these smaller digits. And I give the example 100, which nicely gives my last 2 digits. But if I do something like 8, it doesn't relate to this number as much, but it still pulls the data from like a more random part of the number, let's say. Okay. And we've included the seed for 2 reasons here. Number 1, we want to make it a lot bigger. So if x is 0 or 1, 2, 3, or 5, this is going to be a whole lot more regular. So by adding the seed, which we're going to make a really big number, notice I made it long, it makes it much bigger. And the to the power of 5 is another thing to make it really big. Okay, so that's our random function. Now that we have our left random and our right random determined, we can compute our noise. So the way this works depends on your interpolation algorithm. So if I scroll down here, you can see there's multiple ways to interpolate things. On here we have a linear interpolation. If I have a point right here between these 2 samples, then it's just going to be linear. It's going to determine linearly. And here another example is cosine interpolation. It's more curvy, and cubic looks curvier yet. And then you have all kinds of various techniques which have various complexity. And we're just going to do linear interpolation, meaning if you're halfway between chunk 1 and chunk 2, then make your value halfway between. It's fairly simple in that sense. So we're going to set our noise, float noise, equal to 1 minus prog times the left random plus prog times right random. Okay. So if we think about this, it should make sense. So I said earlier that if you're 0, you're closest to the left sample. So if you look in here, if this is 0, if prog is 0, then this will turn into a 1, because 1 minus 0. So it'll be the left sample plus 0 times the right sample, so it'll be the same as the left sample. Whereas if the prog is 1, this will cancel out, and it'll just be the right sample. And if it's 0.5 or something like that, it would be various levels in between. Very cool. And now I can do return noise, and we're done. That is generating noise for a particular amplitude and frequency. So if we look back up here, we've essentially just generated this. And hopefully that will be apparent when we run it. If we don't get any errors, of course. Implicitly rotate the float to int. Alright, so I thought I was being careful about the cast. You see it mentions line 28 in there, so I can jump down line 28. Yes, okay, that's important. Okay, so noise is a float because, you know, depending on what the prog is and whatnot, these could be varying numbers, not necessarily integer. So to make an integer, I'm going to use mathf.round noise. Do I need to import mathf? No, it doesn't look like it. Okay, so mathf is I believe, I'm not come to think, I'm not sure if it's C# or Unity where it comes from. Probably C# when I think of it, but yeah, this will just round it for us. And oddly enough, even though this gives us an integer value, it will not cast an integer, it'll give me like a float, so I'm going to cast it over there. Alright, now it just stopped yelling at us over here. Cool. When I play, actually nothing's going to happen because I didn't change anything, I just created. Okay, well I didn't get any errors, so there you go, that's good. Alright, now we've got this Perlin noise done for now. And we want to incorporate that over here. Okay. So I'm going to say int noise, or int we'll call column height. Okay. So our column height is going to be equal to noise, which is the object we created up here. And we'll say noise dot get noise. And we have to pass in which column we want the noise for and what the range is. So I'm going to make the column be whatever our I is, and I'm also going to make the I'm going to make the range be our ranges in height. So the lowest it can be is -10, highest it can be is 10. So if we subtract those from each other, take the difference to be 20, and that would be max y minus min y. So that's 20. Let's see. So I want to be 20 in addition to the lowest value. So it's going to be min y plus 20. Okay. So now this will randomly range between -10 and 10 because we start here at -10 and then we add a random value between 20. But this isn't quite random, of course. It's according to Perlin noise. And now instead of making this range from minimum to maximum, we're going to make it range from the min y to whatever the column height is. Okay, so one more thing. The last thing I want to talk about is, before we test this out, is this I variable. So I don't actually want to pass an I because for reasons I didn't explain when I was making this, this kind of breaks down when x is negative. So this really only works when x is positive. So to ensure that it's positive, I'm going to subtract the min y. So when we start, this will be 0, and then as I increases, it will just go up. So it shouldn't be negative. All right. Okay. Now I think we're ready to test, and we should get something somewhat interesting out of it. Generator.noise is never assigned to. Oh, that's a problem. Okay. So I declared this, but I didn't initialize it. I didn't give it a value. So I need to do that. So over here I'm going to say noise equals new Perlin noise. This is calling the constructor that we made. And if you remember, it takes in a seed. And for now I'm just going to give it some arbitrary large number. Put an L at the end to say it's so long. Ugh, my voice is starting to leave me. Well, either we chose a terrible large number or we made a mistake somewhere. Be part of it. Save. Why you no save? Save. Let me double check and make sure that I am actually passing in a positive value in there. So I starts out at min. Oh, okay, here it is. I starts out at min x, -16, and I'm subtracting min y. So right now, it's -16 minus -10, which puts it as -6. And as I said, negative numbers messes with it. So if I make this min x, that should fix it. Okay. I play it now. Alright. Still not seeing anything. What on earth is wrong with you? Okay, this is getting really annoying. Alright, Visual Studio Code just did that error once too often. So I switched back to old reliable Notepad++. And here we go. Jump over to Perlin Noise. Just at a glance. Well, I hard-coded chunk size in there. I need to fix that. Okay, I'm stupid. I added in this min y over here because I want to start at min y. So this is saying this should go up to -10. Okay, I see it completely now. Alright, so I added the min y in twice. I was intending to do the same purpose. I add the min y here because, you know, that's the base. Then I add it here because, you know, that's the base. But that doesn't work because I'm adding it twice, so it becomes too low and whatnot. Okay, so that's silly. Let's take it away here. Or, no, actually, I'm going to take it away here. So this is the height, and here we do the base plus the height. That makes sense. Okay. Now it should work. That took like a longer time than it should have, but hey, I guess that's always the case. It always appears to take longer than it should to fix silly errors. There we go. Doesn't look particularly good. Let's see if we try something else in here. Hopefully just because I picked a bad seed, not because I messed something up crucial. What's wrong? Restart Unity. You can see my lovely Windows default background. Run again. Okay, it might have just been the seed. Okay, so now that I am fairly happy with the way it works, I'm going to do random.range in here, and I make it range between somewhere between 1 million and 10 million. And I'll make them, well, the longs aren't really necessary. 2 billion is about the highest int will go. Okay, now I'm going to rerun it again until I have something that I'm happy with. Something that illustrates everything clearly. Yeah, this is a really good job. So you can see here fairly clear there's 3 sample points. So there's one over here, one over here, and one over here. And it just, in a straight line, goes between the sample points. You see that? So that's what we have right now. Yeah, these ones are a little less clear because the sample points are really close together. But you can see right here, here, here. I do find it slightly disconcerting that it seems to come up with the same 3 or 4 over and over again. But, yeah. I guess one minor thing I like to change is, you'll notice if I do this often enough, that there are a couple of scenarios where it has 0 height, which is fine, 0 is a valid output, but I really want it to, that looks bad when it just cuts off completely down here. So in order to avoid that, like that, I don't like that. So in order to avoid that, what I'm going to do is I'm going to, so this will be between 0 and whatever our maximum is, but instead I'm going to do 2 plus this, and I'm going to, instead of doing the full range, I'm going to just make it 2 less. So our max y minus min y is 20, we subtract 2, make it 18, and now it's 2 plus 18. So it can be between 2 and 20 as a result for our height. Okay, so now we shouldn't get ugly stuff like that. Okay. So this clearly isn't natural looking Perlin noise, but it'll be fairly simple to make this work. Okay, so in order to make this work the way we want it to, we're going to want to do this section over and over again for various chunk sizes. So I'm going to want to declare my noise up here. equals 0. And then every time we do this, I want to go and add that to my noise. Alright, and then we're going to have a while loop right here. And while chunk size is greater than 0, I'm going to just loop through that. Then at the end, for our iteration, I'm going to do chunk size divide by equals 2, and our range also divide by equals 2. And I'm also going to throw a divide by equals 2 up here. So if we look back over here, it's on each step the amplitude is being halved and the frequency is being doubled. So it's kind of the same deal here. Range corresponds pretty much directly to our amplitude, so the range gets halved each time, as it does here, and the chunk size gets divided by 2, which the way I set up chunk size is inversely proportional to frequency. So the smaller the chunk size is, the higher the frequency. So I'm essentially doing the same thing as it's doing here, if that makes sense. But so as we go, we get the distance between the individual samples gets smaller and smaller, and the range those samples could be at, it gets larger and larger. Sorry, smaller and smaller as well. And then because we're doing integer division, chunk size will eventually equal like 1, and then when we divide it by 2, it'll be 0, and then this loop will end. And that should be pretty much all there is to it. I guess about this section, if we want our range to be between, let's say, 8 or something like that, if we didn't divide it by 2 here, we would get a maximum value of 8 on the first iteration, 4 on the second iteration. So we could potentially end up with like 15 as the highest thing, even though we said 8 up here. But if we divide it by 2 first, we would get, it will ensure that it'll be below range. So because range, this is a calculus thing in case you're interested. So then our final range could be potentially range divided by 2 plus range divided by 4 plus range divided by 8 plus range divided by 16. And if we continue this infinitely, you'll find that these two things are equal. So it's a convergent series, and it's pretty neat. But yeah, so I'm taking advantage of that, and I'm basically offsetting this so it would be the next part of the convergent series, and that would make sure that it converges to range. Got it? Cool. So you can look into calculus if you're interested in that. Alright, I've taken it, I think, so let's see the results on that. Gotta restart Unity. Perlin Noise line 20 is unhappy. Line 20. Oh, oops. Yeah, if anyone has insight on this error, why this happens, and why I have to restart Unity every time to fix it, that would be much appreciated. Division by 0. That's not good, is it? Okay, let's see why. It says Perlin Noise line 13. That's where the division by 0 is happening. I had this a few times when I was looking at stuff. Tell me, what inputs give us this strange error? 0, 0, big number. Okay. So the range is at 0 for some reason. Oh, okay. Oh, okay. I remember this one. All right. I know what it is. All right. So I have this loop go on until the chunk size is 0. However, if the range is 0, it'll still keep going. So in my original code, I actually had this little line over here where I said range equals math f dot max 1 comma range. Okay. So if range is bigger than 1, this will return 1. If range is less than 1, 1 will become the bigger of the two numbers, and it'll be 1. So this just makes sure range can't be 0. Okay. Another avoidable error. I can close you out. Now that's going to disappear because it's a good division error and doesn't do it. Okay, so now it looks more natural, yes? Many more natural. Still printing stuff out though. Where did that come from? There we go. We gotta take that away. Alright. Okay, this is the final product. We are done. Well, yeah, this is more or less final product. This is the hard part. We got the Perlin noise down to the point where it generates a random-ish looking terrain, and it looks both natural while being random. So you see, this looks like something. It's not pure randomness, but it looks random enough. There's random patterns in there, and it can look different. So cool. I guess to cap it off, we'll go ahead and make the tops all grass, make it look a little better. So how we can do that? Okay, so right now we're only loading in the dirt prefab. Oop, I'm gonna copy that guy, load in the grass prefab, and then right here before we instantiate the prefab, we're gonna create a variable game object block equals. That's gonna represent which prefab we're gonna do, and I'm gonna do a ternary operator. Do a quick little check. If our j is equal to basically our highest -1, then we want our block to equal to the grass prefab. So we want equal to grass prefab. Otherwise, we want equal to the dirt prefab. So yeah, that prefab. So that's a ternary operator, just a compressed if statement. So if this, do this, else do this. And when j is equal to this, that means we're at the highest part of iteration. Okay, and then here we'll use block instead of the dirt prefab. And then over in our Unity editor, we're going to click on generator, and we have a new field there, and we can go ahead and throw in our grass prefab into that field. Very cool. This excites me. I find this to be pretty cool. So we have random Terraria style terrain generation. Alright, and that's all. So just so you guys know, this is one of a series of terrain generation tutorials I'm going to be making. I'm going to be generalizing this algorithm further to work for Minecraft style terrain generation. I'm also going to be making a similar series of videos for Game Maker, so if Game Maker is more your thing, or if you don't know, if you are confused about how you would apply this to Game Maker, you can try that. And I'm also going to make some more videos playing around with Perlin noise and just how cool it is, you know. Who wouldn't want to make animated Swiss cheese with 4-dimensional Perlin noise algorithms? So, yeah, thanks for watching. Links in the description to everything I talked about. And I look forward to seeing you guys in more videos. So, have a nice day.